All right, in this video, we're going to learn about Unit 1, which is probability. This is Lesson 1, sample space. And the benchmark that we are learning about, which is DP.2.1 for our 8th grade math, is to determine the sample space for a repeated experiment. Okay, so this all relates back to probability. Now, these are an example, or this is what your notes should look like that you received in class. And we will be completing this page in the video, and this is for you to complete for practice on your own. So sample space is a list of all of the possible outcomes of an event. So if you did an experiment or an event and you wanted to know all of the possible outcomes, you would use sample space in order to determine those outcomes. We are not going to learn about the mathematical way of doing this at this time using exponents because it is early in the year. This is our first unit of the year, and most of us don't really remember our exponent rules. So an example of sample space of flipping a coin twice, what does that look like? So you have a two-sided coin, usually heads and tails, and if we flip that coin 2 times, what are all of the possible different outcomes we could have? So you could have heads, 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 tails, 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 or tails, heads. So that is 1, 2, 3, 4 possible outcomes. So our sample space would be 4 outcomes. Now, what if we took that same coin and we flipped it 3 times? We know for sure when we flipped it twice, we had 4 outcomes. So what's going to happen when we flip it 3 times? Well, when we did that in class, all of the different combinations that came up are listed here. Then we took a spinner, and we had a spinning spinner with 4 sections, and you're going to spin it 2 times. So what are all of the possible combinations you could get? Well, these were all of the different possible combinations of spinning a spinner 2 times, a 4-section spinner 2 times. We had a bag or a cup that contained a green, purple, and blue disc. And when you pulled out a disc, put it back, and then pulled it out again, or pulled out a different disc, you could have gotten all of these 9 different combinations. So we had 3 discs, 9 combinations. Here we had 4 sections. We had 16 combinations or outcomes. Here we have a 6-sided die. We're going to roll it twice. What are all of the possible combinations of numbers we could get? Well, they are all listed here, all of the possible combinations. And then finally, if we chose a card from a deck, replaced it, and then chose the card again, what is the possibility, or what are all the possible outcomes? So flipping a coin 3 times, we had 1, 2, 3, 4, 5, 6, 7, 8. A 2-sided coin 3 times had 8 outcomes. A 4-section spinner twice, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 different outcomes. 3 discs 2 times, 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 colors 2 times, 9 outcomes. 6-sided die 2 times. That was 36 outcomes. You can sit there and count to 36 if you'd like. Just trust me. Or we had 5 cards 2 times, and we had 25 outcomes. Are you starting to notice a pattern? I'm hoping so. 2-sided 3 times, 2 times 2 times 2, and that's equal to 8. Well, we had 8 outcomes. 4 sections, 2 times 4 times 4 is equal to 16. 3 colors, 2 times 3 times 3 is equal to 9, and we had 9 outcomes. 6 sides, 2 times 6 times 6 is 36. Well, we did have 36 outcomes. 5 cards, 2 times 5 times 5 is equal to 25 for 25 outcomes. So when you create a sample space, what you saw here were all lists. We created lists. But you don't have to use a list when you're creating your sample space. You could also use a tree. So a tree is meant for experiments that are repeated more than 2 times. So, for example, when we flipped that coin and we flipped it 3 times, our best use of sample space, or our best sample space to use, would have been the tree method. Okay? So our first flip, you could get heads or tails. Your second flip, you could get heads or tails. And then you're going to list it down here again, heads or tails, depending, because you have to keep track of if you started with heads or started with tails. Then your third flip, again, you could have heads or tails, heads or tails, heads or tails, heads or tails. So this tree is keeping track of how many times we flipped the coin. And here we did 3 coin flips. First flip, second flip, third flip. So here's the combinations. We could have HHH. We could have HHT. So you would list that here. You could have HTH. You could have HTT. Or you could have THH, THT, TTH, TTT. Well, there are 8 possible outcomes. Trees are used mostly for coins or 2-sided objects. You would not use a tree to do marbles or cards typically. You would be best suited to do a table. Okay, so now we're going to look at a table. This is not for experiments repeated more than twice. So your limit is 2 times that you could use a table. Okay, so fill in the table to represent the sample space for the repeated event. The first event is the vertical column. The second event is the horizontal row. So it would be this and then this. So when we fill in our table, we would fill in YY. Here we would fill in YB. First draw Y, second draw red, YR. BY, BB, BR. RY, RB, RR. Finally, we have a list, and your list is your least visual method, but it's also probably one of the most problematic that I see because students seem to always forget a combination. So it doesn't keep track of the combinations or the possible outcomes for you. Okay, but if we had A and we place back the card, we could pull another A. So we have AA. You could also get BB, CC, or DD. So that's the first list of items we could place underneath the cards. Then you could get AB, AC, or AD. Then you could get BC, BD, BA. You could also get CD, CA, CB. Finally, DA, DB, and DC. So this is considered a list. This is what most students I see do most often until they learn that they could have used a table. The table just keeps it a little bit more organized. So again, just to recap, our sample space or our outcomes. Sample space is helping us determine the number of outcomes we could have in our experiment, in our repeated experiment. So 8 possible outcomes. Is there a pattern? 9 possible outcomes and 16 possible outcomes. So we had 2 sides, 3 flips. Again, 2 times 2 times 2 is equal to 8. We had 3 marbles, 2 draws. We had 9 outcomes. 4 cards, 2 draws. 4 times 4 was 16 for 16 possible outcomes. All right, now you're going to complete this practice page on your own. That's why it's called practice. It's for you to complete, the student, to build your proficiency and your fluency. And completing this in Canvas. The reason why I want you to complete this in Canvas and not just on the paper is so that you can see how you would actually have to complete this or answer this in a test situation, a digital test situation, and also on the FAST. All right, that's it.